Good afternoon, ladies and gentlemen, and a very warm welcome to the General Jeffery Soil Health Award Finalists webinar. For those of you who might not know me, I am the National Soils Advocate, as you can see from this very bold banner behind me. My name is Penny Wensley. I begin by acknowledging the Ngunnawal people, the traditional custodians of the land here in Canberra, from where I'm hosting this event, and I pay my respect to their elders, past and present, and to the traditional custodians of all the lands across Australia from where you may be joining us. It's truly a pleasure to facilitate this webinar today, which is part of the Landcare Australia webinar series. I'm going to be talking to the winner and the two finalists of the inaugural General Jeffery Soil Health Award, which was presented in August this year at the sadly virtual, but nevertheless very successful National Landcare Conference. Firstly, a little bit about the award. It was established by my office, the Office of the National Soils Advocate, which is located within the Department of Prime Minister and Cabinet. And the award honours and perpetuates the work of Australia's first National Soils Advocate, the late Major General, the Honourable Michael Jeffery. The award is open to any individual farmer, land manager, extension specialist or educator who's making a truly exceptional contribution to soil health in Australia. The award quite simply recognises what we like to think of as Australia's soil health champions. Today, in this webinar, you're going to hear more about the achievements of the first award winner, Emeritus Professor Lynnette Abbott from Western Australia, and the other two finalists, New South Wales' Robert Quirk and South Australia's Brian Hughes. But before I introduce these three marvellous finalists, some housekeeping. We're going to run the webinar like a fireside chat session. I'm going to be asking the finalists a number of questions, and some of them have been prepared by me in my office. But we're also very interested in your comments and questions, and they can be passed through to me throughout the session. I do encourage you to put in a comment or a question during the webinar, and to do so, you need to be signed into Landcare, Australia's social media platform, Landcare Australia's social media platform called Landcarer. And if you're not already signed in, please do so now so that you're fully prepared. And once you've signed in, you can then type into the comments box underneath the webinar screen. Final little hint, if you're watching in full screen mode, you'll need to exit full screen to see the comments box. So now let's get into the fun part, introducing today's speakers. Our first speaker or the person with whom I'm going to be having a conversation, is Lynnette Abbott. Lynn has conducted pioneering research into symbiotic soil fungi in agriculture and disturbed natural environments during an academic and teaching career that has spanned more than 5 decades. She is also a renowned science communicator, and she's developed the innovative Know Your Soil Biology workshops for farmers and provides hands-on activities on the benefits of soil biota for soil health. Brian Hughes has worked as a soil conservation officer and soils and land management consultant since 1982. He has extensive knowledge of South Australian soils, of their distribution, their properties and management. He's also determined the extent of soil acidification in traditionally non-acidic areas and has promoted the adoption of treatment options to the benefit of many, many landholders. Robert Quirk is a cane farmer, a sustainable agriculture educator, researcher, and advocate. Through extensive study, experimentation, and collaboration, he's developed management practices that have resulted in quantifiable improvements in soil characteristics. Over the past 20 years, Robert has collaborated with 3 universities, I believe it is, Robert, and has developed best practice methods for growing sugarcane in acid sulfate soils and has boosted soil organic carbon levels on his Tweed River farm from 2 to 6%. As a long-term Landcare champion, Robert also won the 2006 McKell Medal, which some of you will recognise was the precursor to the Bob Hawke Landcare Award. I extend my congratulations to all our panel members. You've all contributed in significant but very different ways to improving soil health in Australia. We really appreciate the time you've been willing to commit to us today as you continue to do what you've always done, share your experiences, your skills, and your knowledge. So let me come now to some of the questions. Lynn, obviously, I'd like to start with you as the first recipient of the General Jeffery Soil Health Award. You've had such an extensive career in soil health. Would you like to share any particular highlights? And I know that's always a tough question because I know you've enjoyed your life.
Well, I didn't start out thinking I was going to be doing research on soil health. That wasn't the aim. It happened. But I was fortunate in the many years ago to be able to start up a research program at the University of Western Australia on soil biology. Mm-hmm. And it was especially to look at the role of mycorrhizal fungi in phosphate uptake by plants in agriculture. So at that time, there was a lot of knowledge about fertilisers, and people knew very well how to manage inputs to include the appropriate amount of phosphate fertiliser in particular. And in Western Australia, that was very well understood. So my role was to see how mycorrhizal fungi, which were common in all soils, how they could have a role in this process. By working with someone in a different field, by working with a plant nutritionist who is a soil scientist, and understanding from the side of the plant nutrition and the fertiliser inputs to the biology, to link these two together was actually probably the best part of what my research career has, or the direction it's taken. So it's aiming to understand how we can match biological benefits from soil, so that what the roles in nutrient cycling and other contributions that biology makes to the inputs. So whether they're fertiliser inputs or biological inputs, just matching those together. And that's been really the thrust of what I've been doing. It's complicated because there are no simple answers. And it depends, and I'll probably mention it later, how it depends on working with land managers. It's not something you can study in the lab. And it's been a challenge to investigate it from this point of view, to try and understand how we can get the most out of the biology by balancing with the inputs. So and Western Australia's got wonderfully nutrient deficient soils in which to explore these challenging questions. So that's been a good thing.
Not everybody would think it's wonderful to have deficient soils, but it certainly gives you a challenge. Can I bring you on to these workshops that you set up? Because this is all about making the connections and linking academic and research work out into the field. And these Know Your Soil Biology workshops that you established, I understand, have been very effective with farmers and other land managers. So tell us a bit more about these. Are they ongoing? How long have they been going on? Over to you.
Well, they started many years ago, and they have evolved. But they started at a time when there weren't lots of workshops around. And nowadays there are many opportunities for farmers to learn about soil biology. So the times changed. But at the time I started these workshops, it was with the Land Management Society of WA, and they had other Know Your Soils workshops, but not biology. So we started out I would go to a farm, usually commonly, with microscopes and with a package of my teaching on soil biology. So this really arose from the fact that I was in a university teaching about soil biology, but the actual implementation of this knowledge wasn't happening in the field, except for rhizobia, of course, which nitrogen fixation in legumes was well known and well practiced. But just the more general application in nutrient cycling wasn't common at that time. So it was more a conversation with the growers in these workshops. So we'd spend a whole day exploring the concept of soil fertility and learning a bit about the biological processes. But I think I probably learnt more because it actually helped me understand why we couldn't implement this knowledge easily. And it's taken many, many years now to be very well recognised as important. But it's more, how do you bridge that gap between scientific knowledge and implementation? And this was what I really enjoyed, learning in the different regions of Western Australia, the constraints to farming practice, and the reason that biological processes were probably not high in the priority list. So these workshops evolved. They started many years ago, but lots of people contribute now in this area. But my role was to sit with farmers for a whole day and just talk. So I learned lots, and I hope they learned as well.
Terrific. Now tell me, one of the nice things about this prize is it's not just for the prestige and the honour, but you actually get $20,000. How are you planning to spend this? It's one of the criteria that it has to be some continuation of your work, but tell us what plans you have for this.
Well, it's quite opportune because I have just recently, I'm just finishing now a Landcare grant, a Smart Farms grant, in which we were developing a soil health app. So this app has a lot of information on it, and it's ideal now I can incorporate this information plus other information into the website soilhealth.com. So this website's it was set up many, many years ago before people even talked about soil health really, and it's been sitting there pretty much neglected. But now I've got a chance to really rejuvenate it and have a good chance to put this new information from the app, but also other information will go on the website. So this is wonderful for me because it brings together a lot of information on that website, which we haven't had a chance to do till now.
That's terrific. And it's really tuning all of this into a new generation. Everybody is operating in a very different way with apps and new systems. So one final question before I move on to talk to Brian. We often get messages through various functions that young people are very interested in what they're going to do when they graduate. And what would your advice be to students today who are contemplating the possibility of studying soil science as a career or a related science? One of the things that has bothered me over the last decade as patron of Soil Science Australia is that there has been an ageing cohort and a diminishing number of students choosing to study agriculture and soil science and related sciences. And I'm thinking that's changing because soil and soil health is moving up the agenda, is clearly getting more traction. But what would your advice be?
Well, it's not common for young people to decide they want to study or be a soil scientist, I guess, but there are many avenues for them to participate in careers in soil science. And this probably includes things they wouldn't normally think about. And so the physics, chemistry, biology, maths, there's a lot of need for technological input into soil science, modelling. So I think the wider view of what soil science is now available to young people. And participation in a lot of the Landcare activities that all depend, maybe they often focus on plants, but the plants grow in soil. There are many ways people can get involved these days, and including urban agriculture. This is an area that's probably been, urban agriculture, I probably meant urban soil science, because we all have soil outside our front door and we put concrete on it and all sorts of things. But what's happening to our soils and pollution, all the things that need a lot of research behind them. So there's many ways people can participate from any discipline, really. And so it's just by young people being involved in something of their interest often can lead into finding someone who's doing something of interest to them or learning more about soil. So it's not a direct career path. It can come from many directions. And I know some very wonderful young soil scientists who came not even realising they were going to be soil scientists. So it's an open book, and but we still need to let people know about it, of course.
Absolutely. Thanks very much, Lynn. So let me turn to Brian. Brian, as I told everyone, you've been working on soil acidification in South Australia for 3 decades or more. Can you elaborate a bit? Tell us about the occurrence and the expansion of soil acidity in your home state, because it's synonymous, I think, a bit with South Australia. So.
Yeah, well, probably historically, we're a bit behind some of the other states. So Western Australia, New South Wales have had perhaps a longer history in some ways. And I suppose in South Australia, up to probably about the late 80s, that was more of a problem on the high rainfall sort of pasture areas. And a lot of our cropping soils, I suppose, we have a lot of calcareous soils and patches of other soils in amongst those. And we started to see, I suppose, in the 90s, perhaps some of the higher rainfall cropping areas acidifying, particularly in surface layers, through to right through to today, where we're seeing sort of the low and medium rainfall areas where they're not buffered by natural lime, patches of paddocks or sandy soils and red soils that haven't got natural lime in them. We're seeing the acidity develop, I suppose, and get down to sort of critical pHs, probably almost right throughout the cropping areas where the soils are non-calcareous. I suppose very much the expansion in recent times has been under cropping. And we still have that sort of high rainfall pasture areas that have had a longer acidity problem. I worked on Eyre Peninsula in the late 80s and ran the first soil acidity field day in about 1989. And at that stage on Eyre Peninsula, there was one landowner who was liming, and he was actually had come from Europe, and he limed in Europe, so he limed there. And now you go back there now, and there'd be a couple of hundred farmers, I suppose, in that district that have got some type of liming program happening.
What do you think that you've mentioned particular farmers, but how much has the message got out and farmers have really learned about identifying soil acidity problems and managing them? Are the key messages getting through as much as we need them to?
Look, I think there's more to be done still, but we're still finding areas where farmers are picking up issues with sensitive crops like lentils and that, and not picking up they've got an acidity problem. But we have, broadly speaking, across the state, we've seen, I suppose, the liming rates go from something like 70,000 tonnes up to about 250,000 tonnes over a bit over 10-year sort of period. And we've sort of got a team of, I suppose, I work with a team of people across the state through different agencies and landscape boards, trying to sort of raise awareness of acid soils. Certainly some of the agribusiness people are now picking it up pretty well as well. I suppose, there's certainly more to be done. There's certainly areas that we pick up people haven't recognised. And one of the, I suppose, for a South Australian perspective, again, one of the issues we have is often it might only be part of the paddock that's got a problem. And there might be calcareous soils that are 8.5 pH in parts of the paddock, through to stuff that's sort of now acidifying and getting down to those levels below 5. So you very much get this sort of in the sort of lower medium rainfall areas, this sort of, I suppose, pattern effects across the paddock, which are based on sort of soil type and land use, and certain areas acidifying, not the whole paddock, if that makes sense.
Yeah. You mentioned lentils. What other crop choices are farmers making to help them manage these issues?
Yeah, so I suppose, certainly the sensitive crops in there, so sort of lentils, beans, fava beans, and barley to some extent. But we also see on the other end of that, we see some farmers have gone down growing more acid tolerant plants. So they, things like lupins and most varieties of wheat I suppose, are really quite tolerant of acid soils these days. So you depending a bit which way they go, if their soils are getting too acid, it restricts the number of crop types they can grow successfully sort of through their property.
Right. And you mentioned a couple of the other states. I've been very involved since I took up this position approaching a year and a half ago now, with the development of the National Soil Strategy. And one of the things is that's driving this is that we really want a genuine sense of national cooperation and collaboration. How much contact and interaction do those of you working in South Australia have with colleagues in Western Australia? How much is the information shared? What sort of data do we have? And we're working on a new national database, but I'm interested in the sense of all of you out in the field in different parts of Australia as to how important it is to try to bring all the states and territories together. We're not exactly having a national cabinet on it yet, but I'd be interested to know.
Yeah. Look, I think, certainly within SA, we've got pretty good coordination through a state acidity committee now, and I suppose nationally, the GRDC has certainly been supporting some national get-togethers, electronically these days, I suppose. So we've had certainly contact with New South Wales and Victoria and also WA through those. And prior to COVID, I suppose we had a couple of get-togethers physically as well. And I think that's really important because I suppose some of the newer issues to do with acid soils are really linked to things like no-till farming and how do you get the lime down to the layers that you want to treat in the soil, and some of the modern farming systems, I suppose, that have perhaps changed what was done 30 years ago and how they treated it. And I think there's been a range of sort of also conferences and types of things that people have been presenting at. So it is coordinated reasonably well, and in some ways the issues we're having in different states overlap. So the issues about trying to prevent subsoil acidification or treat subsoil acidification, which is probably some of the harder bits. The stuff to do with comparing different treatments and lime quality and various things, they can be to some degree consistent across the states.
Let me just have a follow-up on that. What do you think is going to be the most significant problem in the future for your state? Is it surface acidity or what you were just mentioning, subsoil acidity?
At the moment we certainly have a lot of emerging areas, and that is surface acidification. But in some ways, if we get it early enough, it's a lot easier to treat. And one of our key messages is trying to get people to treat it and get it to a pH that you prevent, the deeper acidification of the A horizons, and which then, if you prevent that, you're certainly fixing things early. If you allow it to go deeper into the profile, it's a lot longer to get it back. So that's certainly where we've seen deeper acidification develop, and even just what we call stratified profiles. That takes a bit longer for things to be treated, and a lot harder to get the lime and the pH change down into those sort of deeper part of the soil horizon. I think certainly from a South Australian perspective, there is plenty of lime. So it's not, but we do have some regions where we run out of agricultural lime still even now. So that, and I imagine in interstate that can be an issue at times, and also probably the price interstate is our limes are probably relatively cheap in SA, but there are some areas where the lime price is quite a bit higher as well.
Thank you very much, Brian. And I'm going to come now to Robert, and we're going to shift the focus to acid sulfate soils. But Robert, I was in Cairns earlier this year for the Soil Science Australia and the New Zealand Society of Soil Science joint conference. And we went out in pouring rain to have a look at some soil pits which had been completely swamped. Some of them had collapsed. And we were looking at how difficult, or at least it was a real reminder of how difficult these soils are to manage. I imagine that there's people participating today who haven't experienced the sort of problems that you have to deal with your soils. Could you tell us a bit about them and what the challenges are involved in actually managing to be a successful cane farmer in northern New South Wales and in Queensland, where you're dealing with acid sulfate soils and a lot of rain at certain times?
Thanks, Penny. Look, it's they were first identified by a Dutch scientist back in the 1700s as the cataclays or soils from hell, and I think Lynn's already mentioned soils from hell. The Netherlands only has about 3,000 hectares of it, but here they were formed after the last sea level rise in the glacial period. So they're formed from ocean sediments. They're very high in sulfur. So when they're exposed to the air or drain, they produce sulfuric acid. And our floodplain here on the Tweed has 50 tonnes of sulfuric acid per hectare oxidised in the landscape. So it was never going to be an easy fix. The scientists that we worked with thought it was probably going to take about 500,000 tonnes of lime to neutralise that, and then we wouldn't be able to grow anything in it anyway. So what we did was develop some practices that let us farm over the top of it. That's micro-environments. In other words, we're planting above the ground, very small area. If we do lime, and I don't lime a lot, because we've got more than enough calcium to grow our crops. If we do use lime, it's only for the environment. So, and we had a major fish kill in 1987, and that was the release of about 0.5 tonne of sulfuric acid per hectare. So the walk-away option was 100 years of fish kill. So we had to find some way of keeping the acid in the landscape, and it's been very successful. We've reduced our discharges by over 80% just by having a good drainage system. And we thought that if we produced we've got 100 tonnes of sulfuric acid in the land, 50 tonnes of sulfuric, enough to kill the fish for the next 100 years. And I might add, that fish kill was 18 months of the whole river, just totally sterilised. So it was massive, but it doesn't happen anymore. The sugarcane draws the water down similar to the trees in the Murray-Darling. So we're just stopping the water coming out, the acid coming out.
So effectively, this means that not only on farm dealing with your challenges, the changes that you're introducing have delivered or are delivering off-site environmental benefits. So better management of soils is having a much larger impact.
Well, the fish don't die anymore. That was chronic. It was 30 kilometres of river. It's a very short river. 30 kilometres of river for 18 months. There wasn't a living thing in it. It was crystal clear from the release of the aluminium and iron into the system. Pardon me. We started harvesting without burning. Well, I did, and that then gave the iron flock something to cling to, so it didn't release anymore. And what we found was the organic matter and Lynn, I'm talking way above my pay level here, the microbes and bacteria in the soil the pH went up by from 2.5 to 5.5, and that wasn't from lime. That was more from organic matter and cultivating the microbes. We think.
You think?
Well, it worked. Whatever happened, it worked.
Well, that's what we want, and you improve productivity. I mean, and you improved soil carbon.
Yeah, we went from about 50 tonnes per hectare. Well, I did, from about 50 tonnes average per hectare to 90, and in a good year, 100 tonnes per hectare. So,
and soil carbon?
Soil carbon has increased from 2 to 6% on average, and up to 8 OC on the good spots, which is 14% organic matter. So yeah, it's been really good. We were fortunate to be working with a whole lot of really good scientists from New South Wales, Uni, ANU, CSIRO and Southern Cross, and we had 12 PhD studies to set us on the right track. You know, we'd try something, the student would do the work, we'd supervise it, and you know, if it worked, we'd do it, and encourage everybody else to.
Yeah, I'm glad you mentioned about the universities, because I'd been told that you'd worked with 3, but I wasn't sure which were the 3, or at least I didn't remember them from reading the nominations. You know, sometimes there's a degree of competition rather than collaboration, and universities are very proud of what they're doing and in their own areas. Do you collaborate separately with each of them, or do you bring them all together? I mean, are these PhD students from the different ones? How does it actually work in practice?
Well, the guys from ANU and New South Wales were colleagues at different levels. So CSI are the same, and we had a invited student from we've now had 4, I think it is, from Southern Cross, mainly because I served on the National Acid Sulfate Soil Committee representing national farmers for quite a few years. We've been to pretty much every jurisdiction in the country and looked at the acid sulfate soil problems. So I've been to all the states and seen how it works. And Ryan, I did go to Murray Bridge and talk to your dairy farmers up there when in the middle of the drought, when the cracks in the ground, the cattle were falling down them. So it was a massive problem there. Yeah.
Heavens.
Yeah. So, yeah, I've been fortunate to, be able to work with some really top people.
I have one last question before we move on to dealing with some of the ones that are coming in from the audience. Robert, you mentioned, I thought, the Netherlands when you were telling me about the soils from hell. You had a Churchill Fellowship, as I recall, and you went overseas to share knowledge about acid sulfate soils and managing them in Australia with countries overseas. I'm keenly interested to know more about this, because part of my role as National Soils Advocate is to build international connections and to promote actively the sharing of Australia's strengths and capabilities in land management and soil management. So tell us a bit about your Churchill Fellowship experience. They're great fellowships and very interesting things that you're able to do.
I started off in Louisiana, and I was to speak with the soil faculty at Louisiana State for half an hour, and 2 hours later I was exhausted, and they knew these things existed, but they didn't know what they looked like, and they were digging out coal out of the ground and putting the overburden back, and then nothing grew. They then realised it was acid sulfate soils and they couldn't do much about it. Went to Florida. They didn't have any major problems there. They got a lot of calcareous rock, coral, and that drains through. So the peat wasn't causing a problem there. Went to Maryland's in Maryland's University with a really good friend of mine there, Bill Fanning, Professor Fanning, and yeah, they had the stream from Baltimore, the river, which escapes me. They dredged that 70 years ago and put it up in heat, and it's still discharging acid 70 years later. So they then came to Australia and worked with us, stayed with us, and looked at our problems. And then on to the People's Republic of China, where they have quite a problem, using massive amounts of nitrogen fertilizers, up to a tonne to the acre, which was impossible for the sugarcane to use anyway, and that was causing more acidity. What they've found now with some of the research is that the more nitrogen you put on in these acid sulfate soils, all it does is go down and drive the pyrite oxidation, causing more acids. So we've got to be really careful how we deal with them. The knowledge is there. I don't know that if people wanted to read it rather than research it, it would be probably, it's already been done. Look, the World Acid Sulfate Soil Committee is meeting in Adelaide in November next year. So it'd be, we might talk offline. You may be able to be one of our speakers, or
Yeah, terrific. Thanks very much, Robert. Let me do a bit of connecting of the dots. Brian mentioned about soil acidity in WA. Lynn, you're based in WA, but your area is soil biology. How does soil acidity link to soil biology?
Well, the organisms in soil are very diverse. So you're talking about a huge range of capabilities and functions. So organisms respond to their environment, and some of them can tolerate alkaline soil and some acid, but the bulk of organisms in soil don't prefer those extremes. But the classic example of the effect of acidity on a group of soil organisms is for rhizobium. So the nitrogen-fixing association with legume and bacteria. So there are some organisms, some of these rhizobia are not tolerant of acidity. So there's classic research from Western Australia by John Howson and Mike Ewing, who set about to investigate this for some of our pasture legumes. And the important point was that select the rhizobia for the soil, for the pH, related to the pH, but they also had to get the right plant as well. Our plants can vary in their tolerance of acidity, and so can the microbes. So it's a very nice way they looked at this to find the tolerance of the bacteria to fix the nitrogen and the tolerance of the plant to survive in the more acid soils. And I think that's an example of a specific case. But more generally, when the soils become very acid, then they're not going to function in the same way. So a lot of functions will slow down or become, or shut down even, and that can involve breakdown of organic matter. So when soils are stressed in some way, often the microbes have to work harder. They produce more CO2, for example. So, but you get that whole process slowing down or shutting down. So it's a natural thing that most of the organisms prefer or function best in a less acid soil. But as our soils become more acid, then you can get adaptation, but perhaps not to the extent that is required. So the idea of liming to bring the pH up, but the incorporation of organic matter has an effect as well. So it's not just a one thing fixing it. It's a combination of factors. or management practices to fix the process. But if you're looking after the microbes, they don't like acidity generally, and so you want to balance that. But the rhizobium story is classic. It's a very interesting story where they had to select the organisms to suit that more acid soil, and you get more productive pastures. That's the work that was done here by the group at Murdoch and the Department of Agriculture.
Thanks, Lynn. I've got a question from Levi Opus for Brian. Do you have any thoughts or messages for new scientists?
Yeah, good question. look, there's a lot of things still to be learnt, I think, in agricultural systems. Like we've certainly got a PhD student in our acid soils project who's looking at how we can better measure, I suppose, line movements using infrared techniques and in the soil, and I think just understanding some of these things will lead us to much quicker ways of measuring things. We've got a lot of interest in how do we measure different carbon forms in the soil, and really to get on top of the whole, I suppose, carbon storage and all these sorts of things. We need to be able to do some of these things, and there's sort of technological type of things that we need to develop. The soil biology area that Lynn talks about, there's still many things we don't know and understand, and certainly DNA profiling and things is certainly improving that dramatically. I think there's a lot of research work in agricultural systems and moving through the next few decades. A lot of areas for young scientists, whether it's chemistry or physics or biological sort of stuff, I suppose.
Right. Well, thank you. Just let me ask all of you what you think is going to be the biggest challenge in your area, and it may be your area of producing as a farmer, or your area of providing consultancy, or your area of research and applied research. And I guess the background to my question, obviously, is our changing climate and that big challenge that we're all dealing with, recognising that we're going to have highly variable weather patterns, and we're already experiencing more extreme weather events, and they're going to be more frequent, more severe. That's going to have a lot of implications, I would have thought, for soil and the management of our soils and water. And of course, they're connected. But I just want to drill down a bit into your own areas of focus, and in that big picture context of changing climate, see how you think that's going to play out in your own area and where you're going to need to focus. So, Lynn, kick off with you first.
Well, it's a narrow focus, but it has a big implication, I think, and that is that balancing or understanding the relationships between inputs and what is grown, and then the maintenance of a soil that's resilient to the climate. So it's sort of embedding a biological base into agriculture. So you can grow plants in soil without worrying too much about the biology, and it can be very productive. But for resilience of the system, to maintain good water storage in the soil and to enable the plants to be grown, sustainable. That's an old-fashioned word, but it's to maintain a resilient system for forever, or for however long we want. Because without incorporating the knowledge of biology in the system, we are going to come unstuck further down the path. So some of the things that the organisms in soil do that inputs of the nutrients don't do alone, the working between the organic matter, the soil organisms, and the soil structure, gums or exudates that are produced by these organisms, they accumulate over time. So you need, it's just not a quick fix, it's a sort of a gradual process that will evolve, that the soils will improve. So to me, that everybody thinks perhaps, oh, well, we'll lose production. I don't think in the long term that's necessarily the case, maybe very briefly. But building, and this is what comes to me from people who are managing land, after about an approach that incorporates this knowledge, after about 3 to 5 years, something happens. And what happens? Well, something's happening, but they say over time. So I think it's very important to understand this timeline, that incorporating biological knowledge and getting those organisms to do their thing over a period of time, and it might be 5 years in some situations. It'll differ in different soil types, of course, but understanding that and getting that, being confident that that will be an outcome with the climate change. And I think it'll be different in different environments and for different crops, but keeping that in mind as a goal, I think, is to me something that is going to be useful into the future.
Thanks, Lynn. Let me come to you, Robert, and very interested in, I mean, the key takeaway for me from Lynn's comments is that we really need to incorporate biological knowledge more, pay more attention to soil biology, and it's going to deliver dividends. And you're someone that's already, you've already got that message. So what do you think are going to be the big challenges, and what you're going to need to focus on in this changing environment that we're all having to deal with?
Penny, first off, sea level rise will have the biggest effect on us. On the coastal strip, we're only half a metre above sea level, so we've got floodgates, pumps, and we pump the water out. At this time last year, we had a 5-day flood. It was only a metre deep, but it just stayed there, and Penny, it killed all my microbes. It was like there was a dead cow in every paddock as the water went off, but the recovery was pretty quick. So it mustn't have killed everything. The recovery of it killed all the cane, and then the canes came back fairly quickly. So when I did start harvesting this year, it was most of the cane was 6 to 7 months old instead of 12 months old. Microbes, very important. I don't understand a lot about it at the moment, but I have a PhD work doing his research here at the moment. And he said, we've got and Lynn, you're probably the only other person on the call who'll understand this, carbon being exchanged for nutrients. And sorry, Brian, you probably might as well, but I don't know a lot about it. But this young student has been to every other cane growing district, and even though the microbes are there, they're not exchanging carbon for nutrients, only here on this place. So something we've done, and we think it might be that immediately after harvest, green cane harvesting, we spray with 5 kilograms of urea per hectare. There's about a tonne of sugar on the cane, and we're changing the carbon to nitrogen ratio in the. So a few days after harvest, my trash doesn't float away like everybody else's, and while it breaks down fairly quickly, it's in a much more stable form. So it doesn't go back into the atmosphere as CO2. It stays there, and the microbes feed off it. So look, our big problems are going to be sea level rise, Penny. Look, there's no question it's critical. And 1.5 degrees over the next 1,000 years will mean we're about 30 metres higher the ocean than it is now. And that's just through the thermal expansion of the Great Southern Ocean. Every degree is 20 metres to sea level rise. And the last time our Earth's temperature was about what we were anticipating, the ocean was 3 degrees warmer, sorry. The ocean was 70 metres higher than it is now. So, yeah, look.
Yeah, well,
I'm not
an island continent
an
where most people live on the coast, it's a big issue, and it's a big issue for a lot of people. But in terms of your talking about sea level rise, this is another area on which I and my office have been focusing, and quite a lot of people in Australia, about salt-affected soils and soil salinity. And that is going to, saltwater intrusion is obviously going to contribute to that problem as well. But that's the subject for another whole webinar. Let me come to Brian. Brian, big challenges, changing environment. How's that going to affect your priorities and the focus of the work that you've been dealing with for so long?
Yeah, look, I think from my perspective, when I started out, my number one focus was probably erosion in soils, and we saw through modern farming and no-till and stubble retention, we've seen a huge reduction in that. But in line with the modern climate events, we're certainly seeing an increase in things like the adverse events, the fires, and are probably our areas now that we're seeing the bad erosion is actually following things like fires, and how we sort of manage and recover those areas is pretty important. I think, from a soils perspective in South Australia, is really understanding that range of soils and that precision approach to how we deal with them. So it's, not treating all your soil the same. It's really having different inputs, and trying to balance those inputs. There's certainly things like acidity, if we can balance the nitrogen input, will, not over fertilise or whatever, will lead to lower levels of acidification. I think there are some landscape issues like Slindy and that are appearing under modern farming, and how we deal with those, I suppose, in some ways too, is a challenge for us into the future. But I think, from my end, it's probably that understanding the variation and the balance of how we treat some of those agricultural soils, and we do, in low rainfall areas now, we can grow really good crops on much lower amounts of rainfall than perhaps 20 or 30 years ago. And we've seen major advances in many ways, and we've got to sort of recognise that. And we have farmers growing crops on 100 mils. Didn't used to happen. Used to be blowing away 30 years ago. So we've seen a lot of adaptation there in those areas already, and how they sort of, I suppose, cope with the next lot of changes, I suppose, to some degree, will depend a bit on that soil variation and how they can keep that moisture in the system. Even in vineyards and these sorts of things, we see a lot of interest in making the soils more resilient, and certainly things like organic matter and compost and all those cover crops are all part of that system of improving that, so it's that you can deal with the hot days better.
Yes, absolutely. And I mean, a couple of key messages. This issue, we have always had big challenges in Australia, highly diverse soils, fragile, old, weathered soils, and we made mistakes in the way in which we managed the land and in our practices. And we've learned a lot. And as you say, we had big challenges. You started with erosion, and we've got less of that now. I am very proud of the way Australians can demonstrate adaptability and resilience, and I genuinely believe we've got a lot of knowledge and experience to share with people with similar challenges. But the second thing that you said, the word for me was balance, and there's a final question from an audience member, Simon Goodhand, who says to all of you, and I'll need quick answers because I'm keeping an eye on the clock. How do you strike a balance between advising farmers and land managers on specific soil constraints such as acidity, individual nutrient deficiencies, and their immediate treatment, as opposed to management of soil health with holistic, longer-term management approaches? So it's that issue of balance between specificity of soil challenges and a bigger picture of integrated management, which of course was what my predecessor, Michael Jeffery, was very focused on, integrated management of the land, taking into account soil, water, crops, animals. So it's nice to be brought back to Michael Jeffery's idea, and I'm going to ask each of you to give me a minute on how do you strike a balance when you're advising farmers and land managers on the specific things with that bigger idea of a more integrated approach. Lynn?
I'm not an advisor, but I think that...
No, but you're running those workshops for farmers.
But I think there's two things going on at once. There might be an immediate need for specific knowledge to deal with a problem that's in front of somebody, and then there might be more holistic knowledge for the longer term. So everyone can contribute in different ways, but I think this comes back to also the point about the different disciplines communicating in these discussions, so that the information that flows in these channels isn't... Sometimes it will be on something specific and sometimes it'll be on something more general, but collaboration in the explanations is probably important in the longer term. So it's also about the receptivity of the people who are listening. So that's important in this equation. Not everyone wants to know the same answer. So I think we tread around this space and we collaborate in doing so.
Thank you. Who's next? Robert.
Yeah, this is a difficult one. I've never a prophet in your own land. I don't do too well telling people around here what to do, but I've been to 35 countries as a paid advisor, and they hang on every word. So, look, I think it's, as Lynn said, it's got to be of interest. We had a soybean field over the other. People came from everywhere just to see how they could improve their soybeans growing on the coastal strip. So, yeah, I really don't know what the short answer is to the questioner, but look, get the topics that are interesting to people and how they can improve their bottom line, I guess. I think that's a really important thing. Farmers want to be here for the long term and make a dollar. Thanks.
Yep. Thanks, Robert. Brian?
Yeah, I think perhaps along that same theme a little bit. I know the farmers I know would love to be able to improve their soil in the long term. and I suppose you've got this sort of short-term dilemmas of, you know, are these practices contributing to that, or are they going the other way? But I think there's probably, you know, there's a lot of practices can achieve both. They can achieve both, you know, improving the soil in the long term and improving the current production system. And I suppose it's probably understanding those limitations and avoiding the ones that sort of go the other way, if that makes sense.
Yep, absolutely. Well, I think that draws our discussion today to a close, and I thank the audience members who sent in some questions. My thanks again to all our panelists for their time today as part of this webinar, and for all that you have contributed to in the past and are going to continue to contribute to promoting soil health, which of course is my passion. Lynn as a researcher and science communicator in the field of soil biology, Brian as a consultant working on determining the extent of soil acidity in South Australia and promoting the adoption of treatment options, and Robert, as we've heard, a successful cane grower and sustainable agriculture educator who's developed what we'd have to say is best practice for growing sugarcane in acid sulfate soils, and who has, as we just heard, shared his skills widely. Robert, you said people don't listen very well, but when you go out elsewhere, they're hanging on every word. Well, I've been hanging on every word because one of the greatest things is to learn from the people who are out in the field, people like you who are true champions of soil health. May I remind you that nominations for the 2022 award opened this past Sunday. Once again, we launched it on World Soil Day, and they remain open until April 2022. It's really wonderful to be able to offer this prestigious award again. And so if you or anyone you know is helping improve soil health and inspiring others, please nominate now. And I'm going to say farewell. I'm going to slide to the right, and my policy advisor in the office of the National Soils Advocate is going to close off this wonderful webinar. Thank you all.
Thanks very much to Penny for her presentation and facilitating this event. And thanks ever so much to the three finalists, Lynn, Brian and Robert, for your input today. It's been absolutely excellent. I'm sure there are many people who have hung on every word. What I would encourage anybody online to do is to apply for the 2022 General Jeffery Award. There's information on the website, generaljeffreyaward.com.au. It's open now and it closes in April. So I'd certainly encourage you all to apply. So thank you very much. And this is the close to our webinar. Thank you.